In this example, we're not getting into the equation of an ellipse yet. I want to focus more on how the different parts are related and go that route. And in a different video, I'll work with the equation of an ellipse. But here, we want to graph an ellipse and list all the parts of an ellipse that has these three properties. And so as we work with these properties, I will simultaneously graph them and do work on the side to make my list of the parts, okay? So let's get started here. And I just realized I had a typo here. The focus is at 2.9, not 2.5, okay? Okay, I will first plot the center, which is at 2, 4 right here. That's my center. And then my focus is at 2.9, which is up here. So that's a focus. And right away, since this is my center and this is a focus, I know that another focus, let's do this, okay? The parts that are given I will graph in black, and the parts that I'll add are going to be graphed in blue. Okay, so I'll make a note of that over here. Calculated parts in blue. Okay, so 2.4 is my center, 2.9 is a focus, and because this is a focus and this is my center, I know that another focus has to be opposite on the other side of my center, and this one's 5 units up, which by the way tells me that my C distance is 5 because my C is distance from center to focus, so let's write that over here. C equals 5. I need to go 5 units below my center to get my other focus, so 1, 2, 3, 4, 5. So there's my other focus. So I can go ahead, let's write the center over here. Even though it's already listed, I'll make a complete list here. I also know my foci. There are 2 of them. The top one is at 2.9. That was given. And let's stick to our pattern here. I'll write those in black. Okay. But my other focus that I was not given is down here at the order pair 2, -1. Okay. And I know C is 5. Okay, so I've taken care of my center and my focus. I can't do anything else with those just yet. I did get my C value though. The endpoints of the minor axis are 3 units from the center. So here's my center. My minor axis is perpendicular to my major axis, and I know my foci are on my major axis. So my minor axis is measured left and right. So I go 3 units right, 1, 2, 3, and 3 units left, 1, 2, 3. So now I can come over here and I can write down the endpoints of my minor axis. Okay? The one on the right is the order pair 5, 4. And the one on the left is -1, 4. Very good. Now, that also tells me my B distance, because B is the distance from the center to a minor axis, or minor endpoint of the minor axis. So I know B is 3. And as soon as I know C and B, by the way, I've taken care of all the given information now. As soon as I know C and B, I can determine A. Let's determine A. And I can do that with the equation for an ellipse. C squared equals A squared minus B squared. So I'll plug in C and B. So C is 5. That means 5 squared equals A squared, I don't know, minus B squared. So 25 equals A squared minus 9. I'll add 9 over to get 34 equals A squared, and take the square root to see that A is the square root of 34. Now, how does that help me in my picture? A is the distance from the center to a vertex. So C and A are always measured in the same direction. So this was measured up and down. So this will be measured up and down as well. B is measured the opposite direction. So this in this problem was measured left and right because we already knew C was up and down, so B had to be left and right. So square root of 34 equals 5 point something. Okay, it's bigger than 5, smaller than 6. That's all I really need to know to be able to graph it. So for my center, I'm going to go up 5 point something units. So 1, 2, 3, 4, 5 point something. That's going to be a vertex. And I'll go down 5 point something from my center to get my other vertex. So 1, 2, 3, 4, 5 point something. And those 2 points are my vertices. Now, let's sort of focus in on these. I'll highlight them in green. Those are my vertices, okay? I need to find their ordered pairs. Now, the top ordered pair has an x value of 2, so it's 2 comma something. The bottom ordered pair also has an x value of 2. So I'm listing both of the ordered pairs with a 2 as the x coordinate. The y coordinate's a little trickier. This y coordinate is 9 point something, okay? And if you want to figure out the decimal, you could give an approximation. However, most computer systems, maybe like my math lab or Alex or something, typically won't accept approximate decimals for these ordered pairs. So you need a more exact way to do it. Now the way to do it is, let's write in our A distance. A is measured right there. A is the square root of 34. So what is the y coordinate here? Well, it's not the square root of 34 because that's not measured from 0 way down here. It's measured from up here, the y value of 4. So this y value is from here all the way down to the x-axis. And if I cut it right here, I know that this distance below that cut is 4 and the distance above is the square root of 34. So I have to add those two together to get this y coordinate. 4 plus the square root of 34 is the vertex at the top. Okay? Now let's find the vertex at the bottom. Again, let's draw in our A distance. Again, still the square root of 34. So how can I get this y coordinate? Well, I'm going to take 4, and since I'm going, that's my y value to start with, I'm measuring from my center, I'm going to subtract the square root of 34 to get me down here, because I'm going downward. So this y coordinate is my starting y coordinate at the center minus that vertical distance, square root of 34. And those are my two vertices. Okay? Those are all the parts of my ellipse. Now I could also describe the major axis length. Now the major axis is the distance from the top to the bottom, the longest distance. In this case, that's from top to bottom. And since A is the square root of 34, that's from the top to the center, and then I've got another square root of 34 from the center down to the bottom, my major axis length is 2 times the square root of 34. 2 times the square root of 34. Okay? And my minor axis length, well, that in this problem, that's going to be measured from left to right. Well, from the center to the right was 3 units, and the center to the left is 3 units, so that's 2 times 3, which of course is 6. 2 times the square root of 34, I can't really get any simpler than that. I could use a calculator to get a decimal perhaps, but 2 times 3 is just 6. Okay, so now I've got all the parts listed over here that I could potentially find. The only thing missing now is my graph. So I'm going to do that really thick because this is really cluttered. The graph passes through the vertices, which are these points highlighted in green, and goes through the endpoints of the minor axis. So I start at the top, go through the endpoint of the minor axis on the left, the vertex on the bottom, the endpoint on the right, and the vertex at the top again. And there is the ellipse. Okay. I wanted to really draw this up though so you could see the relationships between all the parts of this particular ellipse. And sometimes when you're doing these problems, you don't get nice pretty numbers like 2, 3, 4, 5, 7, whatever. Sometimes you get square root of 34, which is 5 point something, and you have to deal with that. Okay? So I hope this video helped, and I hope you'll watch some of my others.